Hello friends, let's start studying about the new unit and the new term which is semiconductor. Now, as we have mentioned that this second last unit, solids and semiconductors, which is that property or what is that property which differentiates conductors from insulators? See, I can broadly classify solids into two parts, right? One could be conductors and another one could be insulators. I'm asking you, what is that intrinsic property which separates conductors from insulators? You must be guessing that the conductors conduct electricity, insulators do not. But why? What does insulator doesn't have, which conductors have? For example, even conductors and insulators are made up of basic atomic structure or atoms or molecule, right? So why conductors conduct but insulators don't? What is the difference? The difference is the presence of free electrons. Now, what is a free electron or conduction electron? I have mentioned this term again or before when we were studying current electricity, that free electrons are those electrons which jump from the valence shell and get out from the vicinity of atom, and they are free to move in interstitial voids, and now they can drift anywhere in the voids in the presence of electric field. So those free electrons actually constitute conduction electrons, and that is why current flows. Current is what? Flow of charge. So why conductors have free electrons, why insulators don't? To understand this, we are going to study a topic called energy band diagram. Now, energy band diagram, why do we need to study that thing? That is because we have a very small point. See, suppose there is an atom in which there are 6 valence electrons. So that makes valency 2. Now, out of those 6 electrons, 1 electron gained energy and jumped out of the atom. So that 1 electron is now conduction electron because it is going to constitute current. It can move anywhere in the void. But what about those 5 electrons left in the valence shell? See, the atomic stability is at stake now because the atom which was constituting 6 valence electrons is now having only 5 valence electrons. So there is a fact that valence electrons are shared by more than one atoms when the solid is actually constituted, and this facts give study to the energy band diagram. Let's study it. So the first topic of the chapter would be energy band diagram. For this, we are going to take an example of silicon because later on we are going to declare silicon that this belongs to the category of semiconductors, and we have to study detailed about semiconductor only. Silicon has an atomic number of 14. So what would be the configuration? I'm talking about electronic configuration, exactly the chemistry one. This would be 1s2, 2s2, 2p6, 3s2 and 3p2, right? 6, 7, 8, 9, 10 plus 4, 14. This would be the configuration of silicon. Now, on this side, I'm drawing the energy level. This would be in electron volts, and on this side we have interatomic separation x. Okay, this is interatomic distance. So when atoms are brought very close, that is when a solid is actually formed, consider this cap. The atom of this cap are very strongly bonded and they are very close to each other. So let us say that distance is represented here, and this distance would be that. No two atoms in a solid are actually at 0 distance. So there will be a minimum interatomic separation which will be present in all the solids you can see. Now what we are doing, we have taken an electron or an atom, one atom from this cap outside. What I am doing, I am bringing this atom close to the whole group, whole lot, and we are going to study about what are the changes in energy levels of these shells so that we can figure out what exactly went into change. Okay, so this side I am drawing 1s, 2s, 2p, 3s, 3p. Okay, this is my 1s, 2s, 2p, 3s, 3p. Now these values correspond to some discrete values of energy. Now how is that studied? See, these electrons, these 2 electrons in S shell are in S because they have definite energy which belongs to S only. For example, if they would have a bit more energy, they would be in P, or if they would have some less energy, they would have been present in this P, right? So the energy of any corresponding electron decides it has to be located in S, P or the lower shells, because these shells represent the energy of electrons, right? This one is clear. So we are going to revise some basic concepts of chemistry, that is when electron gains energy it shifts to higher orbits, higher revolving orbits or higher energy levels. When it loses energy it jumps back to lower energy levels, right? So for a valence electron, consider what would be the valency of silicon here, 4, that is 2 from 3s and 2 from 3p. So these electrons, these are valence electrons and they can actually jump out of the atom and they'll be free, which will be called conduction electrons. So when we are bringing an atom close to the solid or the group of other atoms, what is happening? The lower energy levels don't undergo any change, but the higher energy levels start splitting up. Okay, so there will be a point when the energy level will start splitting up of the outermost shell. Now what does this mean? See, these two, 3s and 3p2, these 4 electrons, when the silicon atom was brought in contact or in close vicinity with rest of the lot, what happened? This atom or these outermost electrons, they gained energy due to mutual interaction and they got aggravated or they got in higher energy disturbance state. So they start vibrating. Initially they had a fixed level of energy, but now they are vibrating with what? Let me explain with this example. Suppose right now they have an energy of 0.8 electron volt. I'm just giving you a vague figure and this is just an example. 0.8 electron volt for 3p and 0.6 electron volt for 3s. Now the 0.8 electron volt of 3p is vibrating with 0.7 to 0.9. So how would I show that in energy level diagram? I have to mark different energy levels, right? So instead of marking different energy levels, we have splitted the outermost shell. And when the atom will be brought more closer, the energy gap between these two, this energy gap, will completely vanish and you won't find any difference between 3s and 3p energy levels electron. When the atom is brought more closer, the innermost shells or these energy levels remain intact till the end, but outermost electrons, that is here, what is happening here? See, how many energy levels are present in P? There were 6 and in S 2. So total there are 8n energy levels. But out of 8n, right now what we are seeing is there are 4n filled energy levels and 4n empty energy levels. So we cannot differentiate between which electron belongs to 3s or 3p. All we can say is in this broad energy gap or broad energy level, there are 4n filled levels and 4n empty levels, but we cannot differentiate between which electron belongs to 3s or 3p. And this happened because the electrons got excited, they are vibrating with different levels of energy, and that is why the energy gap between these two shells completely vanished. When this atom is brought more closer to the space or to the remaining atoms of that constituting solid, what will happen? The 4n filled will get completely separated from 4n empty, and this type of band formation will take place. So this is completely empty part, that is 4n empty levels, and this is completely filled part. This is called, this part or this band is called valence band and this band is called conduction band. So conduction band is what? It is that state of an electron when electron actually jumps out of the valence shell and it now starts moving in the interstitial voids, and now that will be called a conduction electrons, right? So presence of electron in conduction band validates the electrical conductivity of any solid. So conduction band, valence band, and these two bands got separated by some energy gap called Eg. This is energy gap. So this is what we have studied about atom. This would be, let's mark this thing like D, C, B and A. So this is A is the actual interatomic separation. So this is how you can define or explain the whole process in terms of points, that when interatomic separation was D, there is no change in energy level of any electron. When it is decreased to C, innermost shells remain intact but outermost shells got splitted up because the electrons of the outermost shells got excited and they started vibrating in different energy levels. So instead of defining it in discrete energy levels, we have splitted the 3p and 3s energy levels. At B point, the gap between 3p and 3s, which gap? The energy gap completely diminishes, and we can say that instead of 8n levels, instead of 4n filled and 4n empty levels, there are 8n different sets of energy level, out of which 4n are filled, 4n are empty, but we cannot differentiate between which electrons belongs to what. And finally, when atom is taken to actual interatomic spacing, that is A, the completely filled level gets separated from completely empty level, and that is called energy gap. So these are the points on the basis of which you have to explain this energy band diagram, and the energy band diagram actually explains us the concept of conductivity in terms of solids. Let's go further.